Have you ever wondered how data travels from a web server all the way to your local area network, like your devices on your local area network, like your cell phone communicating through your wireless LAN or your computers connected via an Ethernet cable back to your home router? How does this all work? How does information get through the internet? This is a mystery to many people. And in this video, I'm going to be explaining that to you in a very simple form. So let's get to it. Now, this web server could be like google.com or any other website, and you're trying to get information from this website to your computer or to your phone on your local area network. In order for the web server to send information out, it first creates a packet. And this blue area here is the packet. The packet has the payload, the source IP, and destination IP. The payload is like all of your digital information, video, text, whatever that web server is sending to you, it is located in the payload area. Now the source IP address is the IP address of this interface. This will be a network interface card, and it will have an IP address assigned to it. Now this IP address would be the source IP address. The destination IP address would be the IP address of your home router. Now, this information here is what we have to send from the web server over to your home router. But in order to get it there, we have to communicate with the MAC address of the interface card. Every interface card, like the card I said here, has a source IP address. That has to be programmed in, it has to be typed in there. But MAC addresses are burned into the network card. It is there when you buy the card. You could never change that. So, and this is how devices communicate. They communicate with the MAC address. So we would put our information here, which is called a packet, into an envelope. And this envelope, just write frame on the top of it, because that's what it becomes. It's called a frame. And that frame is an envelope basically, and it has an address on it, two addresses, just like you would address an envelope, showing who it is coming from and who it is going to. So this would be the sender, which is this interface here. The MAC address of this interface would be here, and the MAC address of the receiving device, which is this interface here, will be written right here. So this is how routers or computers or all devices on the internet talk like that. They actually talk with the MAC address. So it will go from this MAC address to this one in this router. So once this router receives it, the first thing it's going to do is going to look at the MAC address and compare it with the MAC address it has burnt in. And if they're the same, it knows, hey, this is meant for me. So it will go ahead at that point and open the envelope. Just like if you receive a letter, you check to make sure that letter is addressed to you before you open the envelope. The same thing here. It checks to make sure that it is addressed to it, and then it opens the envelope. Now, in the envelope, it will see the payload, the source IP, and destination IP address. The first thing it would look at is the destination IP address to see if that destination is the same as the router's IP address. If it is the same, it knows that this packet is meant for this router. But if it is not, it knows that it has to send it on to another router. So the destination IP address in this case is not the same as this router. So it sends it to the interface that it knows that will get it to its destination. And this interface has its own MAC address. And the interface it is sending to on your home router also has its own MAC address. So these MAC addresses here would change to these MAC addresses. The source and the destination. Okay, this would be the source and the destination. So this frame would be sent from this router to this one. When this router receives it, it will do the same thing. It will check to make sure that the MAC address on the envelope is the same as the one built into its network card, to make sure that frame is really meant for this router. So once that's been verified, then it would go ahead and open the envelope to see this information, which is called a packet. Now, the first thing it will check is the destination IP address, and it will see that the destination IP is the same as the IP address of the home router. You see, even though this information is meant for one of the devices on the local area network, let's say it is meant for this computer here, it's not going to have this computer's IP address. And the reason for this is because this is a private IP address. And private IP addresses cannot communicate over the internet. They will be blocked. So the destination IP address got to be a public IP address. So the IP address for this interface here, for this home router, is a public IP. All of the IP addresses on this side, which is your local area network, are all private. So all of your packets got to have a destination IP address of your home router, not private IP addresses. That wouldn't work. Okay, so now the next thing your router would do is to check to determine where this packet is supposed to go. And how it does this is through something called NAT, Network Address Translation. This is information that being programmed into your router to tell it where to send this information when it receives it, because obviously the router is not the final destination. The final destination is devices on your network. So the router would check the NAT information to find out what IP address it's supposed to be sending to. So what it would do is to change the IP address, which is the destination IP, from this router now to this computer here. So now it would be 192.168.0.3 for the destination IP address. So now it would put this frame back into the envelope, and it will go ahead and change the source MAC address, which is the MAC address for this interface. Now it would put here on the envelope, and the destination MAC address would be the MAC address for this computer's network interface card, would be right in here. So then the frame would be sent from this interface right over to this computer. So that is basically how it is done. And if you are talking about wireless, it is done in a very similar way. When the frame is received by the router, it will do the same thing. It will check the MAC address to make sure it's the same. Once it's the same, it will check the IP address, the destination IP address, and it will find out that this destination IP address is actually an IP address in the wireless area. So it wouldn't send it to one of these computers on the wired area. It will now send it to the Wi-Fi area. Now over here in the Wi-Fi area, one more thing has to be changed. You remember before we didn't touch the payload. We just changed the destination IP address, and that was it. We didn't change anything else. But when it is sent to Wi-Fi, we have to manipulate the payload. You see, on the internet data travels in groups of 8 bits, which makes 1 byte. However, in order to modulate this information, we have to break it up. It is too large for, let's say, 16 cam type modulation. 16 cam require 4 bits of data, and it has to modulate it with a frequency. Let's say 2.4 gigahertz is a very popular frequency that we use to modulate Wi-Fi on local area networks. So let's say we're using 2.4 gigahertz and we're using 16 cam, which requires 4 bits. So we have to manipulate the payload by breaking it up into groups of 4. So once that is done, this information would be sent off to the device on your local area network as 16 CAM. Many of you may not know what CAM is, so to get a really good understanding of the entire process, my next video is going to be on 16 CAM. So I'll fully explain to you exactly what is 16 CAM. So if this video was helpful to you and you would like to see more videos like this one, please don't forget to click on the like button and click on subscribe and notification so that you'll be notified as soon as our new videos are released. My name is Trevor from Telecom Training. Thank you for watching, and I hope to see you in the next video.